everyone, welcome back to my channel. In this video lecture, we will cover a new chapter of physics, that is units and measurement. The comparison of any physical quantity with its standard unit is called measurement. Physical quantities, all the quantities in terms of which laws of physics are described and whose measurement is necessary are called physical quantities. Units, a definite amount of a physical quantity, is taken as its standard unit. The standard unit should be easily reproducible, internationally acceptable. Then fundamental units, those physical quantities which are independent to each other are called fundamental quantities, and their units are called fundamental units. Fundamental quantities are length, mass, time, temperature, electric current, luminous intensity, amount of substance. Supplementary fundamental units are radian and steradian are the two supplementary fundamental units. It measures plane angle and solid angle respectively. Then derived units, those physical quantities which are derived from fundamental quantities are called derived quantities, and the units are called derived units. Example, velocity and acceleration. Definition of fundamental units. The 7 fundamental units of SI have been defined as under 1 kilogram, a cylindrical prototype mass made up of platinum and iridium alloy of height 39 mm and diameter 39. It is the mass of 5.0188 into 10 raised to the power 25 atom of carbon 12. 1 meter is the distance that contains this much of wavelength of orange-red light of Kr86. 1 second is the time in which cesium atom vibrates 91192 approx times in an atomic clock. 1 Kelvin is 1 upon 27, 3.16 part of thermodynamics temperature of the triple point of water. 1 candela is 1 upon 60 luminous intensity of an ideal source by an area of centimeter, which source is at melting point of platinum. 1 ampere is the electric current which is maintained in 2 straight parallel conductor of infinite length and of negligible cross-section area placed 1 meter apart in vacuum will produce between them a force of 2 into 10 raised to the power minus 7 Newton per meter length. 1 mole is the amount of substance of a system which contains many elementary entities. Then systems of units, CGS, in which the unit of length is centimeter, mass is gram, and the unit of time is second. FPS, unit of length is foot, unit of mass pound, and the unit of time second. MKS, unit of length meter, unit of mass kilogram, and unit of time second. SI system, this system contains 7 fundamental units and 2 supplementary fundamental units. Then relationship between some mechanical SI units and commonly used units. Length 1 micrometer equals to 10 raised to the power minus 6 meter. 1 angstrom 10 raised to the power minus 10 meter. Mass 1 metric ton 10 raised to the power 3 kg. 1 pound, this much. Please take the screenshot of it. It will help you in further chapters. Then some practical units. 1 Fermi is equal to 10 raised to the power minus 15 meter. 1 X-ray unit 10 raised to the power minus 13 meter. 1 astronomical unit 1.49 into 10 raised to the power m. It is the average distance between sun and the earth, and 1 light year is equal to 9.46 into 10 raised to the power 15 meter. And when parasec is equal to 3.08 into 10 raised to the power 16, that is equal to 3.26 light years. Then dimensions. Dimensions of any physical quantity are those powers which are raised on fundamental units to express its units. The expression which shows how and which of the base quantities represent the dimensions of a physical quantity, it is called dimensional formulas. Then these are some dimensional formulas. It will help you, and in further chapters also. Please go through your NCERT part 1 of physics, that is with you. At the last, many dimensional formulas are given. Please go through them. It will help you. Then homogeneity principle. If the dimensions of the left hand side of any equations are equal to the dimension of right hand side of the equation, then the equation is dimensionally correct. This is known as homogeneity principle. Mathematically, it is just LHS is equal to RHS. Then applications of dimension to check the accuracy of physical equation, change a physical quantity from one system of unit to another system of units, or to obtain a relation between different physical quantities. Then significant figures. In the measured value of physical quantity, the number of digits about the correctness of which we are sure plus the next doubtful digit are called significant figures. Then rules for finding significant figures. All non-zero digits are significant figures. Example, 4362 meter has 4 significant figures. All zeros occurring between non-zero digits are significant figures. Example, 1005 has 4 significant figures. All zeros to the right of the last non-zero digits is not significant. Example, 6250 has only 3 significant figures. In a digit less than 1, all zeros to the right of the decimal point and to the left of a non-zero digit are not significant. Then all zero to the right of a non-zero digit in a decimal part are significant. Then significant figures in algebraic operations. In addition or subtraction of the numerical value, the final result should retain the least decimal places as in the various numerical values. And in multiplication or division, the final result should retain the least significant figures as the various numerical values. Rules of rounding of significant figures. If the digit to be dropped is less than 5, then the preceding digit is left unchanged. And if the digit to be dropped is greater than 5, then the preceding digit is raised by 1. And if the digit to be dropped is 5, followed by digit other than 0, then the preceding digit is raised by 1. Then if the digit to be dropped is 5 or 5 followed by zeros, then the preceding digit is raised by 1 if it is odd and left unchanged if it is even. Then error. Error is the lack in accuracy in the measurement due to the limit of accuracy of the instrument or due to any other cause. It's called an error. Absolute error. The difference between the true value and the measured value of the quantity. Then relative error. Mean absolute error. The arithmetic mean of the magnitude of absolute errors in all the measurement is called mean absolute errors. Then relative error. The ratio of mean absolute error to the true value is called relative error. Then percentage error. The relative error expressed in percentage is called percentage error. Then propagation of errors. Error in addition or subtractions. If the measured value of two quantities A and B are, then maximum absolute errors in their addition or subtraction is delta x equals to plus or minus delta A plus delta B. Then error in multiplication or division. Let x equals to A, B, or x equals to A upon B. If the measured values of A and B are A plus or minus delta A and B plus or minus delta B, then relative error will be this. So thank you for watching my video. This much for today's chapter. Go through your NCERT ones and go through your NCERT questions. This chapter will be done. And this was for today's video. Thank you for watching. Hope you liked it. Don't forget to like, share and comment my videos, and don't forget to subscribe my channel. Thank you.